Alright, here we go. Implement a trie, a prefix tree. Okay, so you implement a trie, tree with insert, search, and starts with. So the best way to be able to get an idea for this, so this is a prefix tree, but this is basically going to be an object to see if a word exists if I've inserted a word in this thing. You also have a starts with method, and the starts with is returns if there's any word in the trie that starts with a given prefix. So the code is here. Here's a little bit about trie. A digital tree or prefix tree is a kind of search tree and ordered tree data structure used to store a dynamic set or associative array where the keys are usually strings. So you store a dynamic set or associative array where the keys are usually strings. You have an example here. But yeah, that's pretty interesting. So here I have the code, so I'm going to read along here. But what I'm going to do is use this example. So let's take the basic structure of a trie. So we're going to insert the word apple. And so how can that be represented graphically? No idea. I have no idea actually. So each trie we represented with a circle. Nope, don't do it like that. You can do it like this. Yeah, each trie represented with a circle. Now we have this initial trie, and then we want to insert into the children. So like my initial trie is just this, it's just a blank thing. But then what I'm going to do is, this has 1, 2, 3, 4, 5, so I'm going to kind of get rid of, I'm going to make 5 of these. 1, 2, oh, I'm making these too big. Yeah, these are too big. 1, 2, I'm making them too far away. Oh, you know what? This is the right size. Crap. Wait, how do I do this? I'm not sure how to do this. Oh, okay, I can't do that. Okay, wait, hold on. Try this again. So create this one. And then I'm going to create another one here. And then create another one here. I'm going to create 1, 2, 3, 4, 5, right? So 5. 1, 2, 3, 4, 5, and I connect these. So this arrow kind of represents that for this trie object. This is a trie object. Okay, so being a trie object means that this circle here is gonna has those certain attributes. It's gonna have children, and for instance, its children is, the first children is gonna be this thing here, which is an A. Oh my god, I'm actually writing it a P, and then, but I'm going too far. So like this is its children, so I point to its children, and also I say self.n is false. I'm not going to talk too much about this, but I also create ends. Ends equals to false. Usually it's only going to equal true if basically if you don't have any children. So yeah, we go here to P, and then this will go to this P, and this is L, and this is E. So each of these trie objects have children, and I guess when we go to the last one, which I guess is basically going to be an empty one. For this one, what is significant is that ends equals true here. So that's inserting apple into the trie data structure. Now if you were to search, you would basically just have to search through here, you say, well, my first address, if you're searching, let's say, if you're searching Apple, you would basically go through here. You go, well, first character is A, oh, my second character is P, my third character is P, fourth character is L, my fifth character is E, and then you realize you go to the end of the word and you realize, okay, this word, this sequence of characters, or this word is in this trie object. Now, if you search app is not in here, because you go to A, you go to P, you go to P, and you're like, well, it's not in here. And then we could insert something else. So what happens if we insert something different? So what we're going to get is this. So if we insert app, so we insert app, it would create this, and basically this is where ends would equal true. So now if you were to search for app, you go A to P, and then you go to P, and then you'd say, you'd end up going to this node, to an empty trie object child, and if it's in the self.children, and you'd find this. Now this is actually the basic idea of a trie. I think that's most of it. So so if I wanted to code this, actually, yeah, so let me just go and code it. I've coded this before, but maybe I should start over from the beginning. Very well. So I'm gonna, 1 second, I need to bring this over to here, creating a basic trie object. Okay. So here we go. So getting into the code, we initialize our data structure. So what we have seen so far is that our data structure needs to have children. And one thing we know is we need to have that end property, right? So it doesn't matter what I call it, but I'll call it, I guess, the end. Like, does it end? Does it not end? And we'll initially set that to false. The other thing is we want some children, so we have to do self.children equals, and then the data structure for that could be, it could be a list, but if we want constant lookup and we want a value to be another trie object, we would want a default dictionary. So yes, I mean, why am I using a dictionary here? So because if, take these objects here, right? So I don't know if I can draw this. So this is like my first trie object, right? And its children. So its children will be, also I didn't show this, but if you had inserted another word with another letter, like, I don't know, like let's say it had started with G or whatever, then you would have something like this. So the children for this first node, so I'm looking at this first trie object, its children will be equal to A, and it would be the A trie object. This is my representation of a trie object. Sorry, what am I doing? It's this thing, right? And it has this child. And then I want this node to have, my bad. So I have A, and that will be 2A, and then I'll have another one which is G, right? So G, what am I doing? G, which has this one, of course, G, and I don't know what I'm trying to do here, but okay. So anyway, this here will have the A's and the G's so when you're searching here, you search for A, you say, well, return the A object. Searching for G, return the G object, or the value, which is a trie object. So it turns out that would be defaultdict. And then for default dictionary, you need to, if you're going to initialize it with like an empty trie object or a callable object, trie object. I mean, yeah, that's what we want. We want, right? So we'll initialize with a trie. Okay. So then what we can do is, I don't know if we have to use default dictionary, but that would just avoid a key error. So usually you just do it in general. Now insert the word into the trie, right? So if you're going to insert a word into the trie, you want to go until the word doesn't exist, right? If not word, well, first let's get our recursion. So if I put this from recursion, I want to basically return self.children words or word, and I want to take the 0th word, and then I want to, so word 0 is like, I'm taking that key value, and then we just continue to insert. So that key value has a trie object, which basically will have, I don't know, children associated with it, and then insert. Actually, you know what? I'm a little bit confused about this. Let's print out word 0 when we run this. But yeah, normally this would be insert, and you want to insert everything afterwards. Right. I do need to stop it. So if not word, if it goes too far, self.ends equals true. Yeah. Well, do I want to return, or I don't know if I want to return. Oh, this should be else then. Oops. Let's just run code, just see what's going on in the program. Oh yeah. Alright, so did I string object has no attributes self. Yeah, it should be this word 0, right? Or is this a Alright, I'm not sure. I don't know if I still understand this. Dot insert insert word 1 like this maybe. At this point I'm just trying stuff. Okay, so I mean it goes A-P-P-L-E and do I have to like stop it? What? Oh yeah, I know why I'm saying that. Whoops, print word 0. That's my bad. Because eventually it's empty. Run code. Let's see what it gets to. Invalid syntax. Oh yeah, that's true. Okay, fine. You're right. TO. Okay, so I have to put it in here. Okay. Oops, I went too far. Now run code. Okay, so print word 0 is A-P-P-L-E. Okay. What if I print self.children. Okay, default dictionary. So it has a trie object, and then it looks like you insert, I don't know why it stopped here. So you have a trie object, you have A, P, and P. But these are also associated with a different trie object, as I can see over, because there's a different memory in this hexadecimal. So, is this doing what I expected it to do? Well, I don't know. Maybe, but I haven't implemented search yet. So I mean, it does look like what it's doing is okay, let's think about what I'm trying to do here. So here I have self, right? So I take this current object. So the current object is, it's this trie object I initialize, right? I initialize this trie object, so let's say it's this trie object that I initialize. And I mean, for this trie object, we have a dictionary. It's kind of empty, you know. It's kind of empty dictionary. There's nothing in there. So then we go down here and we say word 0 and we say dot insert word. So a word starts changing from apple to all the way down to E, and then it's like cool, and then we go one more, which is empty, right? While you're doing all this, you're basically saying that the children for this object is going to be A, and what, I don't set it equal to anything though, so what's the trie object? I guess it's just initialize new trie object, a new trie object called, yeah, so it just calls, this is how default dictionary I believe works, so it will just give it a value of trie and it initialize it. So like if it was an int, it would have initialized it to be 0, but in this case it's the trie, so initialize it to just a basic trie if you call the trie constructor or without any inputs, which in this problem the trie object has no inputs anyway. So like when I say inputs, I mean like there's nothing here, like I don't know what you would have here, but like A or B or whatever. And also mean that you can call a trie object with just this, or create a trie object with just this function here. This is the way to create a trie object. Now, and so this dictionary here, though, you have A, and then you have this trie object. And the A here really is just a, it's just, what's it, how do you say it? It's just a character, right? So this is good, I think. I believe this is good. I don't know, maybe not. Okay, so anyways, I want to try to get the next step. So the next thing that happens is it goes to the next word. So then word 0 is P, right? So it inserts a trie object for P. So basically, each time we call insert, we call it on a new trie object, right? Because this dictionary is creating a new trie object, initializing a new trie object, and a new memory address in the computer's available memory. So that's what's happening. So that's why also you have to do this. Like I can't do this. That wouldn't work. It wouldn't initialize the trie object. So here it's initializing the trie object, and then you call insert with this trie object. So you call insert on trie. It's basically take, I'll label these tries as different tries. So this is trie A, and we call trie A dot insert word. Word is now PPLE, and then For that, we create this thing. We create B, create a new trie object like trie B, and yeah, so then we do a b.insert ple, and then we create a new trie object with, we'll have p. Why did I put b here? No idea why I put b. P. Try another p, and then we create try. I kind of have to distinguish this one, so I'll say p2. It's a different one, and then we call trie object on this one. When I say it's a different one. It's a different trie object. Whatever. And we call it insert on this with le, and we just keep going along here. So this trie will have these children. I guess this is a weird notation. It will have L trie dot L, and the dot L just means that I'm just saying that it's a trie object that was created with the L. It's just again, it's really just this being called. I don't know. Maybe I should do better notation. Oh crap! I don't know what the legitimate notation is. I don't think. Trie.e, and sure, we'll call trie.e, and we'll call insert on it with the empty string, which will basically create. For this trie object, we'll say trie.e.ends equals true. Yeah, so we do the insert. Oh shit, this is so bad. Right? Right? So yeah, it goes to the trie, and then it'll change this one to true, right, for the trie object that was initialized with the last character. But you have all these trie objects, so just think about this. I just created a tree that has trie, I guess our initial trie, and then it points to trie, and I'm trying to think about how to distinguish these, but I'll just say the trie at A, and then it has a trie, or no, I'll say trie. I'm going to distinguish it. I'm going to just put A here, but that doesn't mean, that just means that it's the trie that is the value for the character A. Maybe I can represent that somehow like this. This is the A trie, and then you go to the P trie, and then you go to the other P trie, which is a different trie, and then you go to the L trie, and then you go to the E trie, which is another trie as well. And then for this last trie, you change, for this trie, change trie.ends to true. Now all the other .ends is at false by default for when you initialize. So you change the ends for this one. This kind of makes me realize that I made a mistake here where it doesn't create a new trie object at the end. In fact, it's a bit confusing to even just put these letters on these. I suppose you set you set this one equal to ends, and this is all breaking down so quickly, but yeah, so this is like goes to the A here, and then it goes to the P here, and then it goes to this P, then it goes to this L, then it goes to this E. But what you're really seeing is you're seeing the word A for the first trie object, which then has this trie at, I'm not going to type it out, but it's a type of hexadecimal, which, you know, represents the memory address that's used, or something. I might be wrong about that. But yeah, so it has a trie at this. and so on and so on. And you just keep going through there. Now, with that being said, okay, we don't need any of this. Don't need any of this. Don't need this. Close this down. Put this down here. So now let's try search. So for search, I would say we're going to do something similar. So we're going to say self.children. We'll search through the children. We'll get what it is, and then we'll continue searching until we get to the end, right? So I would do it like this. And up here, we'll do if. We'll do if not word. So again, I think we want to return. So return self.ends. You just return what it is. So it might be false. It might be true. I think there's one other thing you want to do, because you only want to do this if, right, you have to make sure that the word is in it. So you have to make sure that word 0 in self.children. And the first, it has to be in that dictionary. That character does. If not, you just return false right away. Now, what is that an example of? That is an example of searching the word app before we inserted app, right? But so imagine I have not inserted this part yet. So we go to A, then we go to P, and then we go to this P, right? And then at this P, when we go any further, there is no other object, so we return false. Or, wait, what am I even saying? Wait, well, okay, hopefully, that makes sense. I don't even know what I'm saying at that point, but okay, I'll just carry on then. So starts with, returns if there is any word in the trie that starts with the given prefix. Well, that's kind of easy. So basically, if you get to the end, return true. Right? No. Return true, yeah. If you get to the end of the word, just return true. Else, I mean, that's what it seems to be to me, because in this case, you're just checking the prefix, right? So if you go to the end of the word, you're good. Like, you do have that prefix does exist. The other thing you want to check is basically self.children word 0 dot starts with, my bad, word is actually prefix here. Starts with, let's go. Okay, I'm trying to okay, so that was stupid. I was just trying to get excited, but okay, never mind. Ignore that. That didn't happen. Right. So starts with, I guess, I lost my train of thought, but I just want to move onwards, right? But of course, I need to check if prefix, I need to check that it's in self.children, else you return false, right? If it's not in self.children, you return false. I think this is right. Bro. Did I use word right here? I did. What? What's going on? Oh, I misspelled it. It should be self.children. Wait, how did I not catch that? I don't know. Wait, the search doesn't work. It returned false when it should have returned true. False, false. False, true. That's weird. Can I print print word 0, and also print self.children. Yeah, this is literally just gonna be me trying to understand this for the first time, I guess. Word 0 is A. Okay, so A, P, 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 L, E. What are you supposed to return? Do you return... I thought you returned self.ends. Okay. Let's see what happens here. Yeah, so I'm exploring what this self refers to. I believe it refers to the trie object at E. So see this right here. Yeah, so see the hexadecimal matches with this one. So it's a trie object at E, and I'm just returning the self.ends, right? I mean, this has the property.ends, right? I don't know. I don't understand why it wouldn't. Yeah, so it returns true. Okay, so if it returns true, why am I getting false? For search. Do I have to... Oh, this has to be returned. Oh, I see my problem. Yeah, because it did all the recursive, but it did end up not returning. So that means I need to do return for this. Alright. I'm going to submit it just because, cool. I've done this problem before. I did it a month ago. Surprised how much I forget. I also don't think I really understood it as well. Like, I understand it better now. Like, last time I couldn't solve it, and I had to look on the discussion. And the discussion is what really inspired this solution. The solution may have actually just been taken from the discussion. I don't know. It's like someone came up with such a clever way, and I was like, oh, this makes sense. But this is me trying to understand it, reason through it, looking at the trie data structure, how it works as a prefix data structure, and just how it's searching for these, what do I call these, sequence of characters or words, I guess, or prefixes, or what's the proper word, but this is a sequence of characters in a specific, arranged in a specific manner that spells a word that makes sense, apple. What am I saying? I don't know what I'm saying at this point, but yeah, this does pass. Coolio.